This is question 12, and we are looking at some coordinate geometry and seeing how we can relate the gradients of different lines and that sort of thing. So it says if we've got a sketch of a line, which has got the equation y equals 2x minus 1, and the point A with coordinates minus 2, 3, and there's a line L2 which passes through A and is perpendicular to L1. We need to find the equation of L2. So let's just summarize that bit. We've got y equals 2x minus 1, and we've got the point minus 2, 3. And the equation of L2, the line we've got to find, has got to be perpendicular to this one and pass through that one. So the gradient of this one being 2 means that the perpendicular gradient is that negative reciprocal, minus a half. If we use this gradient and these values in the formula y minus y1 equals mx minus x1, we get y minus y1 equals mx minus 2, so x plus 2. I'm going to double everything. And then multiply out that bracket on the right hand side. Now what form have I got to get it into? Y equals mx plus c. Okay, so let's add that 6 to both sides. And then divide by 2. This is a really funny way around. All right, so you probably could have skipped a few of those steps and got to that answer. That's the answer we need. Y equals minus a half x plus 2. Correct. Part B, we're given some information here. It says the point B and the point C lie on L1 such that ABC is an isosceles triangle with AB equals AC equals 2 root 13. So I'm just going to, on this diagram, just try and pop roughly what's going on here. The length of those sides is 2 root 13. And this is points B and C. So how are we going to work out, it's not work out the points B and C. What we've got to do is show that the x coordinates of B and C satisfy this equation. Now I think that that is going to come from the length of the line. So if I take just one of those lines, so if we take, here's the point A, which was minus 2, 3, remember, and what I've drawn is I've drawn a sort of an isosceles triangle there. I've said it's 2 root 13, but let's take this point here, B. Remember, B is on that line, y equals 2x minus 1. You can't see what I've drawn at all there. Okay, let's say that again. So I've just drawn out a sort of a slightly larger copy of what I had on that previous one. So we've got A, B, and C. I'm going to call the coordinates of B, x, and y, just like that. So we don't know the coordinates of B, but we do know that its distance from A is 2 root 13. So what is our distance formula? Well, the distance between 2 points is basically Pythagoras' theorem, so square root of the difference in the x coordinates, so let's do that, plus the difference in the y coordinates, and we're told that that distance is equal to 2 root 13. So just to recap, what I've done is I've said the distance between these 2 points is equal to 2 root 13. Now I'm going to try and sort of get this into a slightly simpler form. I'm going to square both sides, so 4 times 13 equals x plus 2 squared plus y minus 3 squared. And then I am also going to use the information that for point B and for point C, because they're both on the same line, so I'm just focusing on point B, but this equally applies to point C. The y coordinate is equal to 2x minus 1, so that y there can be replaced with a 2x minus 1. We do a substitution essentially. So x plus 2 squared plus 2x minus 1 minus 3 squared. What is 4 times 13? 26, 52, isn't it? Okay, and now I'm hoping that if I expand these brackets and simplify this down, I will get it into the format that I wanted. So let's have x squared plus 4x plus 4 plus 4x squared minus 16x plus 16. You can see I'm just sort of running out of space here a little bit, so let's try and a little bit quicker. 4x minus 16x minus 12x plus 20 equals 52. And now I think if I take away the 52, which is what they asked us to show. Excellent. So we've got to the right space there. So just to recap, we've used the distance formula to say the distance from A to B must equal 2 root 13. Squared both sides, got everything down, and then replaced at this stage, replaced that y with 2x minus 1. We did a substitution. Y equals 2x minus 1. Okay, part C of the question says, whoops, me knocking the computer. Given that B lies in the third quadrant, and remember, first, second, third, fourth, third quadrant here. So on my diagram, I've labelled that one as a C, so I must have labelled them the wrong way around. That would be a B and that would be a C. So given that B is down here, find using algebra and showing our working the coordinates of B. So what do I need to be looking at? Well, I know that the x coordinate of B is going to be one of the solutions of this equation. There's going to be two solutions to this equation. One will give us, let's relabel them here, B, and one will give us coordinate C. So let's go ahead and solve that equation. So that was 5x squared minus 12x minus 32 equals 0. You can use the formula here. You can factorize. In fact, it does factorize reasonably nicely. So I'll just show you that. So either x equals 4 or x equals minus 8/5. Now, which one of these is it? If you go back to, where is that question book paper? Here it is. Go back to this one. It's clear, given that B is in the third quadrant, that the x coordinate must be the negative number. So this one is the one that we want. I'm going to cross out that one because I don't want that one. So this is the x coordinate of point B. And also, point B lies on the line 2x minus 1. So we're going to double x and then minus 1, which is minus 21 over 5. Like that. And so the coordinates of B are minus 8/5 and minus 21/5. Done.